Hi students, this is my fourth lecture of industrial management. We were studying project management, and in last lecture I have discussed with you critical path method, critical path CPM, in which I have told you about what is CPM and why do we use CPM, where CPM is used. So CPM critical path method we generally use to find out the project duration. What is the project duration which we need? What is the duration which is needed to complete any project without delaying? So critical path method we used to find out project duration, or we used to find out critical path which tells us about the duration of the project. So critical path is that path which tells us the duration of the project. Critical path is the longest part of the network diagram, and this path will give us the minimum time required for the completion of the project. So today we will study one more example. We will see one example. I have shown you here activities. And their time duration is shown also, and then preceding activity, and on the basis of this table we will construct this network diagram, or we call it as precedence diagram. So what is activity A? We have activity A, B, C, D, E, F, G, H, I, J, K till K. We have A to K activities, and their durations and their time are written corresponding to them. Like for A we have 15 units of time, like 15 days. For B 20, B takes 20, C takes 25, D takes 10. So these are the duration which are needed for the activities A, B, C, and their corresponding preceding activities are also mentioned in the table. For example, see, activity A and B do not require any activity. None of the activities are preceding them. So activity A and activity B will start from 0 time. See here, because none of the activities following them, so they will start from 0 time, at 0. But C and D, they follow activity A. See here, activity C is here, activity C and activity D, they are following. They will be started only after completion of activity A, because they are preceding activity A. Okay, so we will start activity C and D only after completing activity A, because in the table we have given here that C and D can be only started after completing of activity A. So we can see here at node 2 C activity A is completing, arrow is moving here, arrow, see here, this is showing activity A. Then at node 2 activity A is will be finished. Then from node 2 we will start activity C and D, because in the table it is mentioned that activity C and D precedes is following activity A. Therefore we will start C and D after A. After that, see, we have activity E and F. Activity E and F following activity B. So see here at node 3 activity, this is activity E and this is activity F. Activity E and activity F both are following activity B. So see here, this is activity B, and we are starting activity A at node 3 and activity F at node 3, because at node 3 we will start activity E and F, and as given in the table, E and F will start only after completion of the activity B. So we are initiating activity E and F at node 3, because at node 3 B will be finished as it is given in the table. Now see that activity G and H both are following D and E. Activity G and H are following activity D and E. So you can see here, activity G is here, this is activity G and this is activity H. Both are following at node 4 activity D and E. So we have done it correctly. At node 4 activity G and H are starting, and at node 4 D and E is finishing. It will be finished. So we can start from node 4 activities G and H, you have to keep in mind that G and H is following activity D and E. So go to the node, that node, at which node both D and E will be finished, will be completed. Then from that node you can draw two arrows for showing activity G here and activity H here. Okay, after that you can see activity I is also following D and E. So I have we have G here, it is also following D and E, H is also following D and E, I is also following D and E. So both three activities will be started only after the completion of activity D and E. You can see from here the G, H, I, these three activities are following activity D and E. So after completion of D and E at node 4, these three activities will be started, G and H and G, H and I. Okay, now you can see J is following activity C and G. So J is here, it is following C and G. At node 5 both C and G is finished, will be finished, and we can start activity J from node 5. Okay, finally we have activity K, it is following I and F. I is here, F is here, both will be finished. You can terminate them at 6, and then activity K will be started at node 6. So as it is a law, we have only one starting and one finish and finishing end for any precedence diagram. So we will finish, or we will merge or terminate all activities J, H and K at node 7. Okay, so we have discussed now how to make a network diagram or precedence diagram. This is a network diagram, precedence diagram, which we have made by using the given table, and by following simple logic that which activity is following which one. So we can draw, and forward means in forward direction we are representing the activity like this, A and B, and different nodes are showing us starting and completion time of the activity, different nodes. Okay, now let us consider here. I have shown here, this is a square and this is a circle. So see here we have a square and circle, here we have a square and circle, here we have a square and circle. So what these two things are representing us? Forward pass, when we will move from starting point to finishing node, and the time written in the square represents forward pass. Forward pass means when we are moving from node 1 to node 7 towards node 7, then the time on a square represents forward pass, and the duration on that will represent earliest start time of that activity. I will tell you later what is that. And circle is representing backward pass. Backward pass means when you will move from node 7 to node 1, when you will move in this direction, when you will come from 7 to node 1. So it is a backward pass. So what does the values inside the circle and square represent us? Inside the square the values written like, see here, inside the square and circle both we have 0 0. Inside the circle and square both we have 20 20 here, 35 in a square, 60 in circle. So what does it represent us? Like, see here, for node at node 1 in a square we have 0. So it means that we will start activity A at 0 time. Okay, earliest starting time. Okay, and come here at node 2 in the square we have written 15 is written inside the square. So what does 15 represent us? 15 represent us we can start activity C only after 15 days, because activity A will take 15 days in its for its completion. So from 0 to 15 it will we will cover, or we will do activity A. Then only after A we can start C and D. Only after 15 days or 15 duration we can start C and D. So inside the square it is telling us earliest starting time of the activity, for the activity which is like C, activity C and D. We can start activity C and D only after 15 days, because till 15 we were busy in performing activity A. Similarly, come to this similarly take one more example here. See here, We have 20 here inside the box, inside the square. So we can start activity E and F only after 20, because till 0 to 20 we were busy in doing activity B. So inside the square it is representing us earliest start time of the activity, and circle is telling us the late finish time. Okay, late finish time of the activity. What does it mean? We can by how much time we can delay that. For example, I will tell you by one example. See, for activity A we can finish it from 0 to 15, but we can delay it by 25 days, because we have some slack here, we have some extra time here, so that we can delay it till 25, and we need at least 15 days to finish activity A. And if we are delaying it, then maximum what we can delay maximum about 25 days. So in circle telling us the late finish time, and square will tell us the earliest start time. Okay. Observations from the network diagram. So what we can observe from this network diagram, some nodes have same value of the labels. We can say some nodes like this, both have 20-20, both have 50-50, both have 70-70, both have 35-35, both have 0-0. These 5 nodes have, both circle and square have the same time, same duration, but we have 2 nodes here, different times are inside circle and square. In circle we have 25, in square 15, in circle 60, in square 35. So these 5 nodes, like node 1, this is 1, 3, 4, 6 and 7. This path has same duration, same time for both forward pass and backward pass for both square and circle. So what it does represent us, some nodes have same level value of the labels, like 1, 3, 4, 6, 7, they have same values, and other except them have different values. So it is a critical path. We can find out critical path by this technique also. What is critical path? Critical path is that path which will give us the minimum time required for the completion of the project. Minimum time required for the completion of the project. So this is the critical path, and critical path will have critical activities. So if you will delay any one of the activity of the critical path, then your project will be delayed. So the activities which are lying on the critical path are critical activities, and if you will delay those activities, then your project will be delayed. So you can see here from this critical path 1, 3, 7, 1, 3, 7, 4, 1, 3, 4, 6, 7. This is the critical path, and if you will delay any activity of this path, then your project will be delayed. So it will tell us, it will give us the duration for the completion of the project. If you will delay 1 day, for example, if you will delay activity B by 1 day, if you will complete in by not in 20 days, if in 21 days, so your project will be delayed by 1 day, because this activity is lying in critical path. So you can see, if you can see from precedence diagram, 1, 3, 4, 6, 7. So this path takes 70 days. This path will take 70 days for completion of this path. So 70 is the duration of the completion of the project. All the other path except this path will take time less than or equal to 70, because those are not critical path. For example, if you will find out, see this one, 1, 2, another path, you can see that 1, 2, 4, 5 and 7. This is non-critical path. It will take time less than or equal to 70. 1, 2, 4 and 7. It is also non-critical path. So we have only one critical path here. We can have more than one critical path, but here we have critical path is 1, 3, 4, 6, 7. And what about non-critical paths? See, I will write here non-critical path 1, 2, 5, 7. It is one of the non-critical path. 1, 2, 4, 7. It is also non-critical path. 1, 3, 4, 5, 7. It is also a non-critical path. So now there can be so many non-critical paths. So those non-critical paths are those paths which you can delay. If you will delay those paths, then they will not affect the duration of the completion of the project. But the critical path is, if you will delay critical activities of critical path, then your project will be delayed. Okay, so 70 days is the duration for the completion of this project. All other paths except critical path will have duration less than that of critical path, hence it will be less than 70. Okay, and now what we have defined, let us define one. I have defined one thing here. I will tell you about float, what is float and how can we calculate float, and what is free float. See, if you will check arc25, you will check this arc25, so circle j minus, see here, let us define one thing, circle j minus square I minus dj. Dij is what? Dij is the duration of the activity. For example, dij means for d31 will be 20, d63 will be 20, d76 will be 20. Okay, so this is the duration of the different activities. If we cover any arc, if we consider any arc, we will consider any arc, then that will be the duration of that activity. And circle j is the time of the forward. Like here, if we consider arc 25, so circle 5 is what? Value inside the circle, it is 60. See here, it is 60, and the value inside the square is 15. For 2, this, see here, for 2 minus d25 is 25, so we will minus 25. So 60 minus 15 minus 25 will give us 20. This is what? This is the total float. Total float means it is the extra time available so that you can delay that activity. I will tell you once again. See what is happening here. Activity C can be started after 15 days, as because after 15 days A will be finished, so we can start activity C after 15 days. Okay, and you also know that time inside the circle tell us the maximum time for the completion of that activity. So you can start activity C at 15 days and you can complete it till 60 days. Okay, you can start activity C after 15 days and you have a time till 60 days. In circle telling us the time of the completion of that activity. But activity C takes only 25 days. So if you will start at 15 and it will take 25 days, so it will be completed after 40 days. 15 plus 25, 40. So you will have, if you will complete that job at 40, then you will have remaining 20 extra days. So this is the total float. This is the extra time which is available to us, so that we can delay this activity without affecting the project duration. So this is the float. Okay, now one thing is free float. What is free float? In free float, we take the value of 55 in the value of square in the forward node, like node 5, minus value inside the backward node, value of the square at the backward node. Here it is 15. 55 minus 15 and project duration, Dij is project duration, 25 days. 55 minus 15 minus 25, it will be 15. So free float available to us for this activity, for this arc 25 is 15 days. So free float will be less than or equal to total float. Total float and free float both are the extra time or the buffer time which is available to us, so that we can delay that activity without delaying the project duration. So how can we calculate total float? It is very simple. First of all, you will make that you have to make a precedence diagram, then make a forward pass, and forward pass is written on square, and backward pass move from here backward to forward, and then you will make a backward pass. I will tell you once again how to make forward pass and backward pass. See, we had made a precedence relationship depending upon the table, as the values are shown in the table. After that, what you will do, we will make here 0. In the square we are making forward pass, so in a square make 0. Then come to at node 2. At node 2 we will complete activity A after 15 days, so we will write here 15. Then come to node 5. Activity C takes 25 days, so 15 plus 25, it will be 40. It will be 40, but we are not writing here 40. I will tell you now why we are not taking it 40. It is written here 55. Why? Let it be. I will tell you now. See, similarly, activities at node 2, we will start activity D at 15 days, and it take 10 days, so 15 plus 10 25, but we have written 35 inside the square. So what is that? I will tell you now. So in forward pass, if at any node 2 or 3 activities are coming, if 2 or 3 nodes are coming, so for forward pass we will take the maximum time. See once again what is happening here. At node 4, activity D is also coming and E is also coming. Activity D will be finished after 25 days, because A will be finished after 15 days and D takes 10. So after 25 days D will be finished, D will be completed. Now come to E. B will be completed after 20 days, and E will start after 20, so E will take 15 days, so 20 plus 15 35. So E will be completed after 35 days. So how can we move forward without completing both these two activities, D and E? So at node 4 we will be available, or we will be free only after 35 days, because till 25 to 35 we were busy in doing activity E. So any activity which can be only started after completing both D and E. So at node 4 we can move forward only after completing both two activities, and it will be completed after 35 days. That's why in this square I have written 35, not 25. So keep in mind, when we will move forward, so what we will do, we will take maximum of those 2 or 3 activities. Like come to see here at node 7. Come to node 7. I will tell you, I have taken 70. Or you can come to node 5 first, then I will go to 7. At node 5, see, activity C will take 25 days, so 15 plus 25, it will be 40. Activity C will be finished after 40. And activity G takes how much time? 35 plus 20, 55. So at 5 both C and G will be done only after 55. That's why I have taken here 55. So we will take maximum of those two. Now come here at activity at node 7. Come to node 7. We are at here node 7. So activities C and G both are done after 55 days. 55 plus 10. See, J will be done after 65 days. 55 plus 10. J will be completed. H will be completed after 35 plus 30. It is also 65 after 65 days. H will be also completed. And for K, 50 plus 20, 70. So both J, H and K, all the three J, H and K will be completed after 70 days. That's why node 7 will be free after doing all those 3 activities after 70 days. That's why we have written here maximum value 70, because after 70 days we will be free. We will complete all those 3 activities. That's why I have written 70. Now when we will move from backward to forward, when we move backward to forward, for backward pass, how we will do? We will write here 70 is inside this, 70 will be inside that circle also. Then minus 20 it will be 50. Okay, then minus 20 it will be 30, but we have written 20. Why? I will tell you later, don't worry. This is 70 minus 30, it will be 40. 30, but here we have written 35. I will tell you now, don't worry. Minus 70 minus 10, it will be 60. Okay, 70 minus 10, it will be 60. Now come here, 60 minus 20, it will be 40. And here 70 minus 30, it will be 40. 50 minus 15 for this part, it will be 35. So we have for backward pass we will take minimum of these three activities. For forward path we take maximum, for minimum path for backward path we will take minimum. So I will tell you once again. See, this is 70 minus 30, it will be 40, but we haven't taken we haven't taken 40. 70 minus 20, 40. 70 minus 20, it will be 50. It is 50 here. 50 minus 15, it is 35, because here we are getting 35, here we are getting 40, and by this path 60 minus 20, 40. So we have taken minimum of those three, it is 35. That's why I have written 35 here. 35 minus 15, it is 20, and here 50 minus 20, 30. So we have taken minimum of those three, so it will be 20. 20 minus 20, it is 0 here. 20 minus this project duration 20, we got 0 here. See, here we have 60 here. 60 minus 25, it is 35, but we will take minimum of those because two activities are coming here for backward pass. So here we have 35. 35 minus 10, 25. That's why we have taken written in the circle 25, because 60 minus 25, it will be 35, but we have taken minimum of those two. Minimum of those two, it is giving us 35 and it is giving us 25. So but we have taken 25 because minimum of 25 and 35 is 25. So 25 minus 15, 25. See, now one interesting thing is that see one thing, here inside the circle we have 25, here inside the circle is 20. 25 minus 15, we will get 10 here. 20 minus 20, it will be 0. So I have told you earlier that for backward pass we take minimum of the value. So minimum is 0, that's why I have written here 0. So for forward path, when you will move like this, so you will take maximum value at the node, and for backward pass you will take minimum value at the node when you will come backward. So after making this precedence diagram and after showing the duration also at the nodes, you can calculate float. Float is the extra time which is available to us so that we can delay the project. Okay, we have here calculated total float, and this you can keep in mind to calculate total float, and this is for free float. How we can calculate total float? For total float, we have here, keep in mind that latest time at node 5 for arc, if we are calculating float for arc 2 to 5, for we are calculating arc 2 to 5. So what can we do? For arc 2 to 5, latest finish time is 60. So we will take latest finish time minus earliest start time, that is 15. Like see here, 60 latest finish time minus earliest start time minus project duration. So we will get 20. This is the total float. Okay, latest finish time minus, this is latest finish time minus earliest start time minus project duration to calculate total float. If you want to calculate free float, how we can calculate? So we can calculate it by earliest start time of forward node minus earliest start time of backward node minus project duration. So this can be calculated total float and free float by using these two logic, or these two formula you can say. So we have considered one example of critical path method. In this example we have find out the critical path and the duration of critical path, that is the duration of the project, and we have calculated total float and free float, and we have also made a precedence diagram by using this table, and we have also mentioned the earliest finish time and latest finish time, earliest start time and latest start time. Okay, so the values in the square is telling us the earliest start time. So we have shown here, this is for earliest start time for activity C is 15, and latest start time is, latest finish time or latest start time is 25, and you can come to if you will see at node 5, earliest finish time is 55 and latest finish time is 60. See, for arc 2 to 5, if I will say earliest start time, for arc 2 to 5 earliest start time is 15 and latest start is 25, and earliest finish time is 55 and latest finish time is 60. So these 4 times we can calculate, or we can see, or we can observe from this precedence relationship. If you will make this precedence relationship by moving forward and backward path, then you can easily tell us all those 4 times of earliest start time, or latest start time, or latest finish time, or latest finish time. So these things we have discussed in this example. If you have any doubt regarding in this topic or in precedence diagram or anything, you can directly message me or directly comment me. I will try to solve your issues. If you have any doubt in another topic, you can also tell me. I will make video, or I will provide notes of those topics also. Thank you. All the best.